Okay, this will be a fourth video on a series of videos dealing with the law of sines and the law of cosines. This particular one will focus on the law of cosines. I want to remind you of the formulas. If you have a triangle with angles capital A, B, C and opposite sides little a, b, and c respectively, the law of sines is stated here. And this is what I used in the previous videos. In this video I'm going to use the law of cosines, and these are the formulas that you have. So basically it states that if you have any triangle with sides little a, b, and c, and angles opposite these sides capital A, B, and C, then if you take the square of any of the sides, that's going to equal to the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle opposite the side you have here on the left. Okay, so here's little a squared, and over here is angle A. Here it's b squared, and over here the angle opposite in the second formula is b. The next one is c squared. Okay, opposite angle is c, and you have it here. So again, you take any side and square it. It's going to equal to the sum of the squares of the other two sides minus twice the product of the two sides times the cosine of the angle opposite that particular side. So these are the formulas. In the first problem, you're given two sides and the angle included. So say solve the triangle using the law of cosines, and in parentheses you have SAS, side, angle, side. So the angle included between the sides is given. So in this particular formula, you don't have enough information to use the law of sines. So we have to use the law of cosines. Okay, so here's what we're going to do. Since I'm given angle A, then this is going to tell me then that if I take the square of any side, and of course the side that's missing is A, so I'll take A squared, and that's going to equal to the sum of the squares of the other two sides. Okay, so this is going to be 3 squared, I just put a 9 here, plus 9 squared, that'll be 81, minus twice the product of these sides. So this will be 2 times 3 times 9 times the cosine of 127 degrees. Okay, so now you just use your calculator. 9 plus 81 minus 2 times 3 times 9 times the cosine of 127 degrees. Compute that out, and then take the square root, and you're going to get A equal to 11.07. Okay, and again, I could not use the law of sines here with the information given, so I have to use the law of cosines. Okay, so there's the formula from the law of cosines. A squared equals to those quantities right there. Compute it out, and we get side A to be 11.07. Now, in this particular case, we normally would find the smaller angle. Okay, and the reason we would do that is because of the ambiguity with the sine. Remember, if you have an acute angle, or I should say if the sine of an angle is positive, then the angle could be acute or it could be obtuse. So for example, I mentioned this in an earlier video, if you take the sine of 45 and the sine of 135, which are supplementary angles, you're going to get the same number. So to avoid that type of ambiguity when you do these calculations, here you would find the smaller of the remaining angles. Now, in this particular case, though, because you're given a equal to 127, you're given an obtuse angle, so you know that the other two angles have to be acute. So in this particular example, it doesn't really matter, okay, because you already know you're given an obtuse angle, so the other two have to be acute. That is, angles between 0 and 90. But I'll go ahead and find the smaller angle anyway, and that would be angle B, because that's the smaller side. Between 3 and 9, the smaller one is 3, so the smaller angle is always opposite the smaller side. So here I would simply say the sine of B divided by 3 should equal to the sine of 127 degrees. Divided by A, which we just found to be 11.07. Okay, so then you would just use your calculator and compute the sine of 127. Compute the sine of 127 divided by 11.07 multiplied by 3. So then sine of B would equal to that quantity. And I could go ahead and do that, so in case you want to see that. So let me go ahead and get my calculator here. So make sure your calculator is in degree mode. This one is in degree mode, so I would then just say the sine of 127 divided by 11.07, hit enter, is that number multiplied by 3, so now times 3. And then sine of B then is equal to this value right there. So I want sine inverse of that, so I'll hit second sine inverse of that answer, so second, and then I go over here and hit answer. So I get angle B then. Angle B is equal to 12.50. Round it out to 2 places. And that's in degrees. Okay. So we're missing one angle. So we got A to be 127, B equal to 12.50. So to find angle C, we know that the angles have to add up to 180. Add those up, add 127 and 12.50, and subtract from 180, and we get C to be 40.50. That's in degrees. Okay, so we solved the triangle. So again, remind you, to solve a triangle simply means to find the missing parts. We're given 2 sides and the included angle. So we're missing a side and 2 angles, and those are the solutions. Little a is 11.07, angle B over here is 12.50 degrees, angle C is 40.50, and that's your solution. so let me clear this. And let's go to the next one. Now again, anytime you're given two sides in the included angle, or if you're given all three sides, you'll use the law of cosines. Obviously here we can't use the law of sines because again we don't have any angles. So we have to start with the law of cosines. So in this particular case, for the same reason that I mentioned in the previous problem, in this case I'm going to find the largest angle. So notice the sides are 3, 5, and 6. So the largest angle would be angle C, because that's opposite side C, which is equal to 6. So according to the formula then, C squared should equal to the sum of the squares of the other two sides, so that should be A squared plus B squared minus 2AB times the cosine of angle C. Okay, so that's the formula that I would use. So basically what you would do then is plug in the values. Plug in where you have a C, you put 6, where you have a B, you put 5, and where you have a A, you put a 3. So I'm going to solve this formula for cosine of C. Okay, so this is going to give me then cosine of C is going to equal to, okay, let me straighten this out here. Okay, so here's what I'm going to do. I'm going to take this term right here, which is minus 2AB, cosine of C, to the other side and solve it for cosine of C, and then I'm going to divide by the coefficient, which is going to be positive 2AB. Okay, so what I'm going to have then is on this side I'm going to have A squared, but A is 3, so this would be 9 right here, plus B squared, but B is 5, so this will be 25, minus, and then this term here is going to come over to this side. Remember, I'm taking this over to the left and the C squared over to the right, so that would be minus C squared, but C is 6, so this will be 36. Okay, and that's going to be divided by 2 times AB, but A is 3, and B is 5. Okay, so now what we're going to do is just compute this out, and take cosine inverse of that. Okay, so let me just use the calculator here. So this will be 9 plus 25 minus 36, enter, and this is going to be divided by, and then I'm just going to put this in parentheses, and this will be 2 times 3 times 5. Enter. And then I want then to find C, I need the cosine inverse of that number. So I'll go second and then cosine of that answer. So second and then answer. And I get C then is equal to 93.82, rounded out to two places. Okay, so this is one of the missing parts. Okay, so we got angle C to be that. Okay. From here I could actually use this formula a second time. With over here on the left side I would have either a 5 squared or a 3 squared and solve for any one of those remaining angles. And then once you have two angles, once you have two of the angles, you add them up and subtract from 180 and you have it. Okay, but you can see this formula is a little bit cumbersome. So since I already know the largest angle is 93.82, there won't be any ambiguity with the sign. I know the others have to be acute, so that's why we prefer to use the law of sines. Okay, so in this case then, I'm just going to set this up and say then I'm going to have, I'll do it up here. I'll do it up here, the sine of A, angle A, divided by the opposite side, which is 3, should equal to the sine of any other angle. Obviously I'll use the one I just found, the sine of 93.82. Divided by 6. Okay, so then you're going to do the same thing that I just did a while ago, except it'll be sine inverse. Instead of using cosine inverse on this one, you're going to say sine of 93.82 degrees divided by 6, multiply by 3, and then take sine inverse of that answer, like I did in the previous part. And I'll get angle A to be 29.93 degrees. Okay. Now, angle B obviously now can be found simply taking the other two angles, adding them up, and subtracting from 180, and I get angle B to be 56.25 degrees. Okay, so setting up the formula for the law of cosines, I get angle C to be 93.82. And then now I have enough information to use the law of sines, so I set up this equation here, and I get A to be 29.93 degrees. Add those two up, subtract from 180, and I get the third angle to be 56.25 degrees. Okay, so that's the law of cosines, which again is generally used when you're given two sides and the included angle, or if you're given all three sides. You follow this procedure, you won't go wrong. In the next video I'll be looking at some applications, that is word problems, of the using the law of sines and the law of cosines. So please stay tuned for that, and if these videos are helping you, I appreciate if you subscribe to my channel, and we'll see you in the next video.